Performing math in Java involves more than just the arithmetic operators. You also want to be able to perform more advanced functions such as finding the absolute value of a number or getting a number's square root. To do those kinds of operations, you use a special class that's built into Java called the math class. And in this lesson, I'm going to demonstrate 5 or 6 of those functions just so you'll see how they work. Let's start off with absolute value. If we want to find the absolute value of a number, we'll start out with a variable with a value of -100. To find the absolute value, we use the ABS function, which is part of the math class. To call that function, we name the class math specifically, followed by a period, followed by the name of the function, ABS, followed by the argument to the function, which would be our variable number. So let's save that program, then compile it. And we'll see that it finds that the absolute value of -100 is +100, which is exactly right. Let's do another one. This time let's take the square root of number, see what we get. So for that we call the math class again, followed by the function we want, which is square root sqrt, and its argument, which is number again. Save the file, go back to our DOS prompt, compile, and run, and we'll see that it cannot determine the square root of -100. So let's modify number's value to 100. Save, compile again, and then run it, and there we'll see that the square root of 100 is 10. Another use of the math function is to find the maximum and minimum of a number. So let's take a look at that. Let's create another variable called number2, and then let's use the function called max to determine which number is greater. So we call that with max after the math class, math.max, followed by the two numbers that we want to pass to the function. In this case, the variables number and number2. And it will return the greater of the two numbers. Let's compile and run. And so it returned the 100. Let's do the same thing with minimum. This time I'm going to copy and paste and just change max to minimum to save a little typing time here. Change this to min. Click File Save. Compile and run. And there we see this time that the minimum of 130 is 30. I mentioned in the last lesson that to perform exponentiation you have to use a function in the math class. That function is POW, and let me demonstrate how that works next. We'll just write out a result here. So let's say we want to take 4 and raise it to the third power. We do it just like that. Math.pow, P-O-W, and then 4 raised to the third power. The base is the first argument, and the exponent you want to raise it to is the second argument. So let's save that. Let's clear the screen because we're getting a little messy there. Compile and run, and we see the 4 to the third is 64. Notice that a lot of these functions return double values. That's to ensure that we don't leave any fractional part out. Not all of these functions will work with fractional parts, but in case they do, they return doubles to make sure that we don't lose any information. We're going to talk more about how you can lose information in a Java arithmetic expression in the next lesson. Let's look at one more function from the math class. This is the round function. Round will take a number and round it up or down depending on the value passed to it. Final double pi equals 3.14159. System out print line math.round pi. Now we're not modifying pi because it is a final, but we can return its rounded value. So let's save that, compile, and run. And so you see that pi rounds down to 3. Just for fun, let's say pi was 3.64159. And let's see what happens when we round up. So we'll compile and run, and you'll see there at the bottom that 3.64 rounded up to 4. So that's how the round function works. So these functions will come in very handy for you when you're doing advanced mathematics in Java. And you should probably become familiar with the math class, and to look at examples of all the functions, just Google Java math class and you'll find a whole listing of all the available functions and the different arguments that they take and the values that they return. That wraps up my discussion of the math class. When performing arithmetic in Java, you'll have occasion to mix data types. For example, where you have a line of code where you're using integers with doubles, perhaps. In some cases that's okay, and in some cases the compiler will complain. Let me show you a couple of simple examples. We're going to begin with the program where we declare a double variable dnum, and then we declare a integer variable num and assign it the value 2. Then we're going to assign the value of num to dnum and then display the value of dnum. So let's compile this program. We'll save it first, then compile it. Clear my screen. And you'll see that the value of dnum is 2.0, even though we assigned num the value 2. The compiler will convert the integer value 2 to the double value 2.0 when we assign the integer value to the double variable. So when you're going from integer to double, that mixing is allowed. But now let's turn the tables a little bit. Let's declare int num and then set double dnum equal to, then assign dnum to num. Now watch what happens when we compile. Let's compile, and there's an error. The error reads, possible loss of precision, found, double, required int, and then it highlights the variable dnum. And that's because when you're going from a double variable to an integer variable, there's a possible loss of data. The fractional part that the double stores can't be stored in the integer variable. So for example, going back to our program, if we'd assigned dnum the value 2.2222 and then tried to assign that to num in this line down here, then it would have lost this part of the number. The computer is doing us a favor by not allowing us to go from a wider data type, double, to a narrower data type, integer. Now let's look at one more example, and here's a conversion that can occur. Let's create an integer variable num, then let's create a char variable c and assign it the value z, that's the letter z. Then let's assign c to num. Here we're going from char to integer. Then let's display the result. Let's save and compile. Then run it. It displayed 122, but that's because char variables store the ASCII value of the character that's being assigned to it. So when you assign the variable z to the char variable c, you're actually storing the ASCII value 122. 122 can be stored in an integer variable, so when we assign the value of c to num, that's perfectly acceptable because we're putting the ASCII value, which is an integer, into an integer variable, which is accepted. So the bottom line for mixed math in Java is to never go from a wide data type to a narrow data type. So in other words, trying to store a double in an integer is not allowed, but it's perfectly okay to store an integer in a double. The compiler will just convert the integer to a double value and then store it in the variable. And then we can of course store chars and integers because a char is only storing an ASCII or integer value anyway. That wraps up our discussion of mixed math in Java. To wrap up this chapter, we're going to perform an exercise where we take some formulas in arithmetic and convert them to Java code. I've put the formulas up at the top of the program in comments. So let's start with the first one. The first one reads x divided by y minus 3. Now we're not sure if we want the division to go first or the subtraction, as it's not made clear. That's what parentheses are good for. So let's run it both ways. The first we'll do it straight as it is given to us. X divided by y minus 3. Save the file. Then compile it. And then run it. And you see we get 3.5. Now let's modify the order of operations by doing the subtraction first. We have to put parentheses around that part. So we'll save it, compile again, and then run it. And you see this time we get negative 13.0. So that's how you would write that formula both ways. The next formula reads 1 divided by the sum of x plus y. So here we do want to do the addition before we do the division. So we're going to say z is equal to 1 divided by x plus y, just like so. Save the file, compile, and then run it. And we get 0.0666 repeating. So now let's look at the next formula. The next formula reads the square root of x to the 6th plus y to the 5th. So here we're going to have to use the math library. So we'll have math.sqrt, that's the square root function, and then we need the PAL function to raise x to the 6th power, and the PAL function to raise y to the 5th power. The formula will look like that. Save the file, compile, and then run, and we see we get 2197.00728 and so on, and we could round that off to 2197.01. Later I'll show you how to do rounding just for formatting purposes. Our last formula is the absolute value of x plus y. Let's change our values of x plus y. Let's make x a negative 13. So if we just got the regular value of x plus y, we just write the formula x plus y. We can do that in our heads, but we'll use the computer just to verify our work. We'll have negative 11. Okay. So if we want to take the absolute value of that, we call the absolute value function. Okay. So we click File, Save, then compile again, and then run it. And then we know that the absolute value of a negative number is a positive number, so the absolute value of x plus y is positive 11, even though just x plus y is negative 11. That wraps up the exercise and should give you at least a pretty good idea of how to convert arithmetic formulas into Java code. And that wraps up our discussion of arithmetic, and now we're ready to move to a new topic, which will be how to get input into our programs. So far all we've used is direct assignment, but what we'd like to do is prompt the user to enter values so that we can have some variation in our input, and then some more on how to output using systemout.print.